Now let's delve into acceleration. Acceleration is the rate at which an object changes its velocity. It's not just about speeding up, it can also mean slowing down or changing direction. Essentially, any change in velocity is acceleration. The unit of acceleration is meters per second squared. It's a crucial concept in understanding how objects move. Moving on to the equations of motion. These equations help us predict the future position and velocity of an object moving with constant acceleration. They're derived from the basic definitions of velocity and acceleration. The three main equations are, first, v equals sine u plus at, where v is the final velocity, u is the initial velocity, a is acceleration, and t is time. Second, s equals sine ut plus frac 1m2 at squared, where s is the displacement. And third, v squared equals sine u squared plus 2a's. These equations are incredibly useful for solving various problems in physics. Let's now talk about the graphical representation of motion. Graphs can provide a visual understanding of how an object moves. The most common graphs are distance time and velocity time graphs. In a distance time graph, the slope represents the speed of the object. A steeper slope indicates a higher speed. On the other hand, a velocity time graph shows how the velocity of an object changes over time. The area under the curve in a velocity time graph represents the displacement of the object. These graphical tools are essential for analyzing motion in a more intuitive way. In conclusion, understanding motion involves grasping several key concepts: displacement, velocity, acceleration, and the equations of motion. Graphical representations also play a significant role in visualizing these concepts. By mastering these fundamentals, you're well on your way to exploring more complex topics in physics. Keep practicing, and you'll find that these principles become second nature. Thanks for joining us on this journey through the basics of motion.